it will become important for you to be able to determine if your continuous variables come from an underlying normal distribution. There are several ways to look at this in JUMP. We'll begin with the Analyze menu, Distribution. Select your continuous measure. We'll do age and BMI and press OK. You'll see here we have both measures with their histograms, the quantiles, and the summary statistics. From your notes, you should remember that a normal distribution is shaped like the bell curve, where its name comes from, with the high point being the mean and then a symmetric distribution around both sides. JUMP displays this in a vertical way. However, you can change it to a horizontal display if you'd like. So remove vertical and it will become horizontal. You can do that here as well. Remove vertical and it becomes horizontal. I'm going to close the quantiles. So close the grays and leave the summary statistics up. And now what I'd like to do is look at what a normal distribution would look like if it had this mean and this standard deviation. So these are our observed values. And of course, it's a little bit uneven here. And this BMI is very skewed, meaning it has a longer tail to the right side. So what would a normal distribution look like if it had this mean and this standard deviation? So I am going to go under the red arrow and look for continuous fit and ask for a normal. And what you can see is that JUMP will superimpose what the normal distribution with a mean of 40.5 and a standard deviation of 9.7 looks like. You can see here that we are higher than the red curve in some places and lower in some others, with the largest discrepancy being here in the 50 to 52.5-year-olds being much higher than the expected level if this were from a true normal distribution. Now, our sample size here is 334, and perhaps if we took a larger sample, we could fill in some of these areas. One of the ways that we have to look at normality is called the normal quantile plot, again from the red dropdown. And click normal quantile plot, and JUMP will provide you with an assessment of normality, which we'll learn about later. Another thing that you can do is to test normality. So down below under the fitted normal, I'm going to make these smaller. Under the fitted normal, you can actually ask for a goodness of fit test, and JUMP will give you a test of normality. We'll learn more about those later. So this is what it looks like for age at baseline. And then if we ask for the same on BMI under continuous fit normal, we're actually going to see that this really doesn't fit well because of what we've talked about in the skewness of BMI, and that we have many more people in the normal to overweight range than we do in the obese and then, of course, morbidly obese range. So we actually wouldn't expect this to be normally distributed. And in fact, you can see that the tails get cut off here. If I extend BMI down to 0, the axis, we can see the rest of the symmetry. And then it's really highlighted here that this is not from a normal distribution, much more so than age. In the case of age, if I change my axis settings to go from 0 to say 80, I can see that the symmetry within age is actually much more balanced. And so by symmetry, I mean if you look at the mean line here, which is about 40, you would expect equal amounts of data on the right and left of the mean if this were from a normal distribution. And in fact, of course, we expect a certain percentage to be plus or minus 1 standard deviation, and a different percentage plus or minus 2, and then almost 100% of our data should be plus or minus 3 standard deviations. It's a closer fit in the age distribution than it is in the BMI distribution. And so in the future, when we are looking at normality, this is where you will find it in JUMP. So again, to review, it's analyze, distribution, pick your continuous variable as your y, press OK. I'm going to leave this as a horizontal, but ask for a normal distribution again. And in this case with weight, you can see that this tail is cut off here. If you do need the horizontal view, remove under histogram vertical. And then of course you can change your axes, and let's say go from 0 to 400 and press OK. And then you can see how well this variable that we collected fits a normal distribution that has a mean of 180 and a standard deviation of 44.8. We will come back to this and the normal quantile plot many times throughout the course of the semester.